For our last example, we're going to take a look at the logical operators project, which you can find in the Fig 06_19 folder. And the purpose of this project is to demonstrate the various logical operators that are built into the C# programming language. Now, if you're coming into C# from other C-based languages, these operators are going to look familiar to you. Specifically, if you're coming from Java, a couple of the operators that I'm going to show you here are not used the same way in C and C++. So let's take a look at this example. In fact, I'm going to run the example first so that you can see the output. And basically what we're doing here is producing the so-called truth tables for the different operators that we have available to us. So let's just talk about the output first, and then I'll go back and take a look at the source code as well. I'm going to try to expand this window a little bit here also so that you can see all of the output. So as you can see here, we have a conditional AND operator, which is the double AND operator, double ampersand operator. And the way this works is it combines the condition on its left with the condition on its right to produce an overall true or false value. Now, the conditional AND operator, as you can see here, only has one combination of values that results in true. If the left expression is false and the right expression is false, the overall expression is false. If the left is false and the right is true, the overall is still false. If the left is true and the right is false, the overall is still false. But if both are true, only then is the entire expression true. Now, the conditional AND operator uses short circuit evaluation. So as soon as it knows that the entire expression has to be false, which is the case if the left-hand side is false, then the right-hand side in those cases would not get executed. So in this third line of the output here, where we have true on the left side, it's not yet known whether the entire expression is false, so we then have to look at the condition on the right side. If that's false, then the whole thing is false. If that's true, then the whole thing is true. And similarly, the conditional OR is going to use short circuit evaluation as well, and will return immediately upon knowing whether or not the overall expression is going to be true. So the conditional OR expression says if either the left side is true or the right side is true or both are true, then the whole expression is true. So if the left side is false, we don't yet know if the right side is true or not. So we have to look at the right side. If that's false, then the whole expression is false. And if that's true, then the whole expression is true. On the other hand, for these last two outputs, short circuit evaluation comes into play because the left side is true. Therefore, no matter what the right side is, the overall expression is true. Now, that short circuit evaluation can be very useful when you have what we would call a dependent condition that you can test first and say if that thing is not true or if that thing is true, then the other expression should or should not be evaluated. So if I need the left-hand expression to be true in order for the right-hand expression to even be allowed to evaluate, I can use the conditional AND operator for that case, and we can do similar things with the conditional OR operator as well. Now, C#, like Java, also has single ampersand and the single pipe character versions of the logical and logical OR operators. And they work just like the corresponding and just like the corresponding OR operator up above, with one exception: they don't use short circuit evaluation. So no matter what, with the single ampersand or single vertical bar, both the left side and the right side of these conditions will be evaluated, and therefore if you have an expression, for example, that has a required side effect of modifying a variable or calling a method, you're guaranteed that the variable modification or method call will occur. Now, we also have the caret operator, which is the so-called logical exclusive OR operator, and this one will evaluate to true if only the left or the right of the expression is true. So if both are false, the overall is false. If both are true, the overall value is true. But if either one is true, then if only one, is true, then the overall expression is true as well. And finally, we have the logical negation operator, which simply reverses the value of a condition. So not false gives back true, and not true gives back false. Now, all of these false and true values that you see down the right-hand side here are the string representations of Boolean values being output. So let's just take a quick look at the program here, and you can see that the way I produced these tables was literally using the false and true values that are built into the C# language. And of course, normally what you would have on the left or right side of these operators is an expression using things like the relational and equality operators to determine whether or not there is a true or false value to the left and to the right of each of these operators. So here's the double ampersand operator, and the value of that expression is going to be converted into the string representation of the Boolean value, which is displayed as the word true or the word false with a capital first letter in each case. And you can see the same tables that I just showed you in the output being produced here in the program's source code.